So in this video, we will learn about parametric differentiation, subtopic of 9.5. So for first part, we will learn about the first derivative of parametric differentiation. So if we have a function x in terms of t and y in terms of t, by using chain rule, we can find the term of dy dx. So if we have x in terms of t, the derivative of this one would be dx over dt. And if we have y in terms of t, the derivative of this would be dy over dt. So in order to find dy over dx, we have to perform chain rule. So basically our dy over dx will be equal to dy over dt times with dt over dx. Let's proceed with some exercises to check our understanding. So example 17, we have to find the first derivative. For example 17, we have to find dy dx for each of the following. Part A, we have x equal to t cubed minus 2t minus 1, and our y in this case is t cubed plus 4t. So first, x in terms of t, we differentiate this one first. We will have dx over dt will be equal to 3t squared minus 2. And for our second part, y in terms of t, if we differentiate this, we're gonna get dy over dt equal to 3t squared plus 4. So in order to find our dy dx based on the chain rule, this would be equal to dy over dt times with dt over dx. So for our dy over dt, directly substitute our derivative before. So we will have 3t squared plus 4 here. And for dt over dx, basically you just have to flip over your dx over dt equation. Here we will have 1 over 3t squared minus 2. So finally, our final answer for dy dx will be 3t squared plus 4 divided by 3t squared minus 2. And that is basically how you find the first derivative by using parametric differentiation. Let's proceed with the second example. Example B, we have x equal to exponent to the power of 2t minus 3 and y equal to t squared minus 3. Same as before, we have to differentiate both equations first. So first, for our dx over dt, this will be equal to, remember on how to differentiate exponential functions. So first step, you just have to copy everything back. So we will have exponent to the power of 2t minus 3 times with the derivative of your power. In this case, you will get 2. So here, your dx over dt will be 2 times exponent to the power of 2t minus 3. Next part, for our y equation, derivative of it will be dy over dt equal to 2t. Now we substitute each of the term into our chain rule. So our dy dx equal to dy over dt times with dt over dx. Following this rule, so substitute one by one. Our dy over dt in this case, just now we already find as 2t times with our dt over dx. Once again, just flip over your dx over dt equation. So you will get 1 over 2 exponent to the power of 2t minus 3. So basically for 2, you can cancel out. Means that your final answer here will be t divided by exponent to the power of 2t minus 3. And that is your final answer. Proceed with our third example. For question C, we have x equal to ln of 3 minus 3t. derivative of this one would be dx over dt would be equal to 1 over 3 minus 3t. And for in order to differentiate ln equation, don't forget 1 over your function times with the derivative of our function here, so we're gonna have negative 3. So our dx over dt here, we can simplify this out. We will get negative 1 over 1 minus t. Next, we have y equal to tangent of t minus 1. So our dy over dt in this case would be, derivative of tangent would be secant squared of t minus 1. Don't forget, you also have to differentiate the function inside, but in this case, derivative of it would be 1. So our dy over dt would be secant squared of t minus 1. Finally, substitute everything into our chain rule. So our dy over dx would be equal to secant squared of t minus 1 times with 1 minus t divided by negative 1. So our final answer here would be equal to negative of secant squared t minus 1 times with 1 minus t, or we can simplify this as secant squared of t minus 1 times with t minus 1. Proceed with the last one. Example D, we have x equal to ln of 1 minus 3t. Once again, we have a ln function, so the derivative of it would be dx over dt equal to 1 over our function inside the bracket, so 1 minus 3t, times with, don't forget, differentiate what's inside the bracket, so we will have negative 3 there. So our dx over dt will be equal to negative 3 over 1 minus 3t. Next part, for our y equation, our dy over dt would be equal to, since we have exponent function here, just follow our rules, so copy everything back, so e to the power of 2 cos 3t. Now we have to differentiate our functions, so we will have 2 times with negative sine of 3t times with 3. Don't forget, we have 3 stages here. So first, for 2, it's a constant, so it does not affect your derivative. Derivative of cos will be equal to negative sine. Copy everything back inside the bracket, so 3t there. After that, differentiate what inside the bracket, we're gonna get 3. So simplify this up, we're gonna get our dy over dt will be equal to negative 6 exponent to the power of 2 cos 3t times with sine of 3t. Now we can substitute into our chain rule, so our dy dx will be equal to our dy over dt just now. We just copy everything back, times with our dt over dx, so we will have 1 minus 3t divided by negative 3. Simplify this one, so our final answer for dy over dx would be 2 times with exponent to the power of 2 cos 3t times with sine of 3t times with 1 minus 3t. And that is basically our final answer.